All right, we're about to dive into a world that is literally all around us, but you can't see it. This invisible world is what makes our most advanced tech tick, and today we're going to see how AI is learning to become its master.
Okay, so think about this for a second. Ever wonder how the glass on your phone is so ridiculously strong, or what makes a solar panel so good at turning sunlight into power? Turns out the answer to both questions, it's hidden in the exact same place.
And that place, it's what we can call the invisible architecture of materials. Yeah, this is where all the secrets to our best tech are hiding, on a scale that is just mind-bogglingly small.
So, the big secret here is a concept called microstructure. And it's all about these super thin, specialized coatings, or films, that are layered onto pretty much every piece of high-tech gear we use today.
So, what exactly is microstructure? Honestly, the best way to think about it is like a material's own unique DNA. It's the hidden microscopic blueprint that shows how all its internal bits and pieces, the grains, the crystals, the atoms, are arranged and how they all fit together.
And you know what? Just like our DNA, this microscopic arrangement determines everything about how that material will perform. We're talking its strength, its electrical conductivity, its optical properties, even how long it'll last. If you nail the microstructure, you get amazing tech. But if you get it wrong, the whole thing can fail. Okay, so if this invisible architecture is so critical, you'd think we'd have it all figured out, right? Well, there's a huge problem. For as important as it is, actually analyzing this microstructure has been a massive bottleneck in science for a long time.
I mean, for decades, this has been such a slow, manual process. You've got scientists hunched over these powerful microscopes, using their own expertise to try and decode these hidden patterns. It's always been a huge challenge. Just look at the traditional process. You're talking hours just to prep a sample, then more hours to capture the images with these giant electron microscopes. But here's the real kicker. Days of a human expert staring at these images, trying to make sense of them, and then weeks to pull it all into a final report. It's just so slow.
So let's just lay it out, side by side. The old way, slow, expensive, and honestly, pretty subjective. I mean, two different experts could look at the same image and come to slightly different conclusions. The dream, the goal, has always been to make this process fast, scalable, objective, and totally reproducible. And that is a problem that is practically tailor-made for AI to solve.
So, how do we break this bottleneck? Well, this is where the hero of our story enters the scene: artificial intelligence. The mission? We have to teach an AI how to see this invisible world. Now, to be specific, we're talking about a type of AI called a convolutional neural network, or a CNN. Don't worry about the jargon, okay? All you really need to know is that these CNNs are AIs that are absolutely brilliant at learning to see. They can spot patterns, features, and objects in images, and a lot of the time, they're even better at it than we are. So how do you actually teach an AI to see something microscopic? It's basically a three-step recipe. First, you train it. You feed it thousands and thousands of microscope images that have already been labeled by human experts. Then it learns. The AI starts to pick out the key patterns all by itself, things like grain size, tiny defects, different phases of the material. And finally, you execute. You give it a brand new, unseen image, and it can analyze it with just incredible speed and accuracy.
All right, so that's the theory. Sounds pretty cool, right? But how does this all work in the real world? Let's actually step into the AI's training ground and watch this thing in action. So let's look at a real case study from the research. They took this stuff called carsin. Basically, it's a super hard protective coating that you put on things like industrial steel to make them way more durable. And it's a perfect test for our AI because its performance is 100% dependent on that invisible microstructure.
And this is where you see the AI's real power. See, it isn't just seeing features. It's connecting the dots to real-world outcomes. It learns that, hey, these tiny surface defects, they're going to predict a weak spot in the coating. Or this denser nanostructure here, that means a harder, more durable material. It's making the leap from just seeing to actually understanding. But wait, it gets even smarter. The AI can also learn to trace the final microstructure all the way back to the specific manufacturing conditions that created it. And that is a huge leap forward. Why? Because it finally bridges that gap between how you make something and how well it's actually going to work. So to test this, the researchers used a different material, a QZR thin film. You see this stuff a lot in electronics. And what they found was that just by changing the electrical voltage when they made it, they could drastically change the surface. Use a low voltage, you get this smooth, glassy surface. But if you crank up the voltage, you get this really different, dimpled, nanostructured surface. The amazing part is the AI can learn to instantly classify these different outcomes. It's linking the process directly to the result. So what happens when you put it all together? When you combine this incredible speed with this new, deeper level of understanding, well, what it unlocks is a future of smarter materials created faster than we ever thought possible. I mean, the numbers here are just staggering. 1,000 times faster. Think about that. What used to take a human expert days of careful analysis can now be done by an AI in just a few minutes. That's not just an improvement, that's a complete game changer for R&D. So, let's just quickly recap the 4 huge advantages here. First, you get automation and speed. Second, you get consistency and reproducibility, no more human bias. Third, the AI can spot subtle patterns that our eyes might just miss. And maybe most importantly, you get predictive quality control, the power to predict how well something will work just by looking at a picture. And all of this together, it unlocks what many consider the holy grail for smart manufacturing. It's a concept called closed-loop control. So what does that even mean? Well, picture this. It's a system where the AI is analyzing the microstructure in real time, and its analysis is used to directly inform and correct the manufacturing process as it happens. Imagine a factory where the AI is the quality inspector, watching the materials get made, and if it spots even the tiniest flaw starting to form, it instantly tells the machine how to fix it, right then and there. What we're looking at here is a fundamental shift. We're moving away from the old way, where you make something, then inspect it, then throw it out if it's bad, to a brand new world where we are engineering our materials intelligently on the fly. And that leaves us with one final kind of mind-bending question to think about. If an AI can understand that deep connection between how you make something, what it looks like, and how it performs, what happens when our materials can start to design themselves?